Okay, in this video we're going to learn about an t-test, and remember the kind of experimental design that you have dictates what kind of statistical test you use. So in this case we have one independent variable with two groups, and it's between subjects, that is different groups of subjects were in our experiment and data were collected from those different groups of subjects. So we have a between subjects design, and we're going to use an independent t-test to analyze the data. So let's consider that scenario. So in this example, it's very simple. Two groups, different classes. We have test scores from those two different classes, and we want to know, do the test scores differ between these two different classes? So on the first column, you can see these are the actual test scores for our different members of class 1. So 50, 75, 80, 95, and 100. And then in class 2, we have 65, 69, 79, 81, and 96. This is the data that we're actually analyzing. I have some additional stuff here, which I'll explain in a second. But this is the actual data. Two different groups. People in class 1 are not in class 2. So here's our T formula. Okay, so let's look at the quantities. And it's really big at first, but it's really not that big a deal. It's made up of things that you've seen before. So this is the mean of and the sub 1 here means the mean of the first group. The sub 2 here means the mean of the second group. So we're going to need a mean for both groups. And in order to do that, we sum them up. So here's your sum of x, right? And then you're going to divide by n, which is 5, and so you get a mean of 80. Same for class 2 here. I've summed them up, 390, right? Divide by 5 because there was 5 observations in this group, and you have a mean of 78. So those are the values that are going to go in there. Then we're going to need the sum of x squared for the first group, and we'll need the sum of x, and then we'll square that. We already had that. We already calculated that quantity there, and then we have n1, so that's the number of observations in the first group, right? So if you look at this information right here, and then of course this information right here, what we have here is we have, in effect, the standard deviation for the first group added to the standard deviation of the second group. Go back and look at those formulas. That's basically what we have here. Now we do have a little bit of an adjustment here to make it the standard error of the mean, in effect. So that's what this mathematical operand here does for this particular denominator. So what we're doing is we're calculating the difference in means, and then we're calculating the within group variability, right? How much there is a spread of scores within each group, and that becomes our denominator. And so what the T is a ratio of this good variance to bad variance, right? So let's calculate that. And as I alluded to, we need to square up each of these. So 50 squared, 75 squared, 80 squared, 95 squared, and 100 squared. If you add those up, you're going to get this number here, right? That's where that comes from, because, that would be this value here, right? I made a mistake. So here's 50 squared, here's 75 squared, 80 squared, 95 squared, and 100 squared. And then if you add those up, that's the value right there. This value is you're summing up x first, then you're squaring it. So we have 400 squared. If you square 400, you're going to get 160,000. So that's where those values come from. We're going to do the same thing for our other sample, right? So 65 squared, 69 squared, 79 squared, 81, 96. Sum them up. There's your value there. And of course, we're going to need 390 squared, which is this value there. So now it's a matter of substituting into the formula. So as I said before, the mean of group 1, mean of group 2 is right here, right? That goes there. Now this is where you could make a mistake, but we want the sum of x, we want the sum of x squared, so we're going to square x first, then sum, so that's this number. So 3350 gets dropped down here. This value is summing up x, then squaring, so that's going to be the 160,000. And you do the same thing over here for the second group, right? And of course, n1 is 5, n2 is 5. We had 5 observations in each group, minus 2. 1 over n1, 1 over n2. And so now you just got to solve. So we're going to solve for t. So the first thing I would do is reduce this top part of the numerator, and then look for other things that you can reduce. So we could divide this ratio out, we could divide this ratio out, we could go ahead and add these two numbers and subtract, right? And then I would recommend converting this to a decimal number, or 1 over 5 plus 1 over 5 just use your calculator to make it a decimal number, and it's going to be 0.4. So when you reduce that, your next step here shows the reduction of those fractions, in effect. Right? So the next thing to do is then add up these numbers, right? Add up those numbers, and then we're there, right? Then you have a ratio here, so you want to divide that out. Anytime you have the ratios, go ahead and divide those out. So we get 266.75 times 0.4, so we get 106.7. Now we have to take the square root of that, so you take the square root of that, and you get 2 over 10.32957. So we're not quite done yet. Well, we divide this out, and our t obtained is 0.19362. What we have to do is we have to find out if this is a significant difference between the groups or not. So we're going to use the table to find the critical t, and we'll go over that in class, but it's just like the other ones. You're going to need some degrees of freedom. So the degrees of freedom for the independent t here is big N minus 2, or it's the total number of subjects minus 2. You can get the same thing by doing little n 1 minus 1, little n 1 minus 1. Also, it's going to give you the same thing, but it's 8 degrees of freedom in this particular case, and when you look that up, your critical t is 2.306. So we compare them. Our t obtained, where our t critical, it's less than our t critical, so we accept the null hypothesis. And that's what we're going to do. For any independent t-test, it's basically the same thing. You just plug your data into there. So what we'll do in the next video is I'll then show you what happens if we start playing around with the power. And you can use these examples to make sure that you're getting the calculations right with the independent t-tests. That's a good thing to do.